In this video, we are going to look at some mathematics of finance. So in this first question, we are being asked to determine 19% of what number is 152. So first of all, anytime you have a percent, you want to always change it into its decimal. And the way that you do that is you'll drop off the percentage sign and you'll move the existing decimal 2 places to the left. So that would represent the decimal for 19%. Now we're saying 19% of what number? We don't know that number. We'll just say it's n. And they want to know when does it equal, or what is equal to 152. So we're going to solve this algebraic equation. So in order to get n by itself, we will divide both sides by 0.19. And so that will tell us, if we get on our calculator and we take 152 divided by 0.19, that number would have to be 800. So 19% of 800 would equal to 152. Okay. On our next question, we have a woman that borrowed $3,800 from a bank for 9 months. A friend was a cosigner of the woman's personal note. It tells me that the bank actually collected 6.5% simple interest and on the date of maturity, and they want to know how much did the woman pay for the use of the money. So we call that interest, and when they call it simple interest, your formula says that I for interest is equal to P, which is your principal, the amount borrowed, times your rate as a decimal, times your amount of time. So in this case, to calculate how much she would have to pay in interest for the use of the money, we're going to take the $3,800 that she borrowed. Her interest rate was 6.5% because it says 6.5. So again, remember, drop the percentage and move your decimal 2 places to the left, so that becomes 0.065. And then it says that she borrowed it for 9 months. Now, we always want to express time in terms of years unless they tell us something differently about the interest rate. But typically, your interest rate is a yearly rate. So if she borrowed it for 9 months, that's out of 12 months in a year. So our time is 9 divided by 12. And then at that point, you're going to just punch that out on your calculator. 3,800 times 0.065 times 9 divided by 12. And what we see is that she would have paid $185.25 in interest. So that's also called what she pays to use, or the amount that she pays to use the money. And then the second part of the question wants to know what is the amount she has to repay to the bank. Well, when she pays the bank back, she has to pay them the original $3,800 that she borrowed, plus she has to pay them the interest, the fee for being allowed to use their money. So if you add those up, she would pay the bank back $3,985.25. Okay, this next one, we have someone who borrowed $4,750 for 4 months from a bank, and this particular bank discounted the loan at 8.5%. What that means is they go ahead and take their interest up front. So we're going to first figure out how much interest she's having to pay to use that money. So again, this is a simple interest formula. So she borrowed $4,750. If her rate is 8.5% and we drop the percent and move the decimal, that becomes 0.085. And then she borrowed it for 4 months out of 12 months in a year. So we're going to first calculate how much interest they're going to charge her. So 4,750 times 0.085 times 4 divided by 12. So in terms of interest, she's going to be paying $134.58. Now, what they do is they take that money up front. So they don't just hand her $4,750. They take the amount she borrowed and they subtract that interest, and they take that money up front before she ever gets the other money. So if we go ahead and subtract, that's going to tell us with how much she actually got from the bank. So notice in this case, for part B, that's how much she actually received from the bank, $4,615.42. Now, if we wanted to look at, well, then how much interest did she really pay, or what the rate really was since they took it up front, we're going to go back to our simple interest formula. So she paid $134.58. Normally you pay that at the end of the note, not at the beginning. And so what we're going to say in this case is she's paying that for the money she received, which was $4,615.42. We want to look at what rate of interest that would be for her specified 4 months out of 12 to really look at what rate of interest she had. So I'm going to get on a calculator and go ahead and multiply my $4,615.42 times the 4 divided by 12. And I get a decimal, 1538. And I'm not going to round just yet, so I'm going to carry those decimals. And then in order to get R by itself, since that's multiplied by R, I will divide both sides by the 1538. And so, again, hop on the calculator, 134.58 divided by 1538.4733. And we get a decimal of 0.08747. Now remember, that's the decimal form. So if we're looking at the actual rate of interest, to change from decimal back to percent, we'll go 2 to the right. And so she would have actually paid 8.75% because of the fact that she had to pay that interest up front. So notice that's a little bit higher than what it looks like. And it's because of the fact they're collecting that interest up front. Okay, on this next one, we're going to be using what's called the compound interest formula. So A equals P times 1 plus little r over n to the power of n times t. So anytime you see a problem talking about something called compound interest, this is the formula that you're going to use. So in this particular case, it says that we have $7,500, and it looks like we're accumulating it, so it must be that we deposited it. And we did that at a rate of 4.5%, so remember, change it to its decimal, 0.045. It was compounded monthly, so your little n represents how many times that is a year, so monthly means 12 times a year. And then you also have that 12 as part of your power, times your t is number of years, and so in this case we have 5 years. So now I'm going to get on my calculator. Be sure you put parentheses where they have parentheses. So 7,500 times, I'm going to open parentheses, 1 plus 0.045 divided by 12, and then I'm going to raise that to the power of, I can either type in 12 times 5 or just put in straight 60 if you want to multiply that first. And so we see that this is accumulated to $9,388.47. Okay, so that is the answer to the first part. The second part, they wanted to know, well, how much interest did they earn? So if you take that amount and you subtract the original amount that they deposited, that tells you how much interest they actually earned. So in this particular case, they would have earned $1,888.47 in interest. For my last question, when you're being asked to determine the effective annual yield, some books call that your APR for annual percentage rate. Some books call it the APY for annual percentage yield. No matter what it's called, you can still use the compound interest formula. And what you do is you look at investing just $1, which they're telling you here, for 1 year. And so if we look at investing $1, P is 1, and it is 4.2%, so R would become 0.042. Compounded semi-annually means twice a year, so your N is 2, and then your N is 2 again, and you're looking at just 1 year. So we always say we invest $1 for 1 year and look at how that dollar would grow. So again, I'm just going to hop on my calculator. 1 times, parentheses, 1 plus 0.042 divided by 2, and then I'm going to raise that to the power of 2. And so my dollar would have grown to become 1.0424. So if you think about that, you started with $1, and now you basically have $1.04, but I'm going to go ahead and subtract it with several decimals. And so that is your growth, basically 4 cents. So as a percentage, if we go 2 to the right, then that's the same as my effective annual yield was 4.24%.